Good day, everybody, and thank you for joining me today. This presentation serves as an overview of my portfolio for the Applied Data Science program at Syracuse University. Syracuse University offers a Master's in Data Science program that prepares its students for a career in the data analytics field. This program offers instruction from faculty who utilize data sets that span multiple disciplines. These include, but are not limited to, marketing, finance, crime analytics, and sports analytics. The benefits of this are that students are allowed to explore different fields and gain experience in applying their analytical skills in different ways. The program is designed to teach students proper data preparation, instill a comprehensive understanding of data, educate students on different modeling techniques, and coach students on handling large data sets. In this presentation, I will cover 3 projects that exemplify my skills which I have learned from Syracuse University's Applied Data Science program. The topics of these projects include sports analytics, image recognition, and Twitter sentiment analysis. The first project is based on the following question: what factors best predict a Syracuse football coach's total pay? For this assignment, a CSV file was given with data regarding the conferences of the different teams, the head coaches of each team, and the pay of each coach. I collected additional data from the NCAA website regarding graduation rates from each school, as well as stadium sizes for each team. After collecting all of my data, I proceeded to clean and transform the data. This was especially necessary with the pay of the coaches because of the large numbers for this variable. I took the log of this variable so that the model would not give excessive weight to this variable. Following, I conducted exploratory analysis of my data in order to better understand what I was working with, and then began my modeling. During my exploratory analysis, I spent some time looking at the different variables in my data set and looking for patterns in the data. To the left is a plot of the different conferences in the NCAA and the number of teams in each conference. As it happens, the conference of the team played a significant role in my model. I used a linear model and included the stadium size, graduation rates, and conferences in order to determine a coach's particular pay. My model achieved an 80% accuracy in predicting a coach's pay. For a Syracuse coach, my model recommended a salary of $3.1 million. In my second project, I analyzed the Fashion MNIST dataset, which is a popular image recognition dataset. The dataset includes pictures of clothing items on a 28 by 28 scale. This dataset was created by a group of computer scientists from Cornell University, and the data can be found on that page. However, with its popularity, this dataset is now available with a variety of packages for Python. The challenge with this dataset was working with the pixels. The pixels needed to be scaled in order to run the analyses. After scaling my data, I proceeded to split the dataset into a training and test set. For my models, I decided on neural networks and naive Bayes machine learning models in order to classify the images. With the two models, there were several differences. The Keras model is a neural network model that mimics neurons firing in the brain. When a neuron fires, it signals the presence of something. The neural network model does the same for classification. Algorithmically, a neural network model has at least 3 hidden layers. Each of these layers help tune the model to get more accurate predictions with each iteration. The downside to a Keras model is that it takes a longer time to run. However, of the two models, it was the most accurate. The naive Bayes model works differently in that it looks at the features in order to classify or distinguish the different classes. The trouble comes with the pixels. The columns or features in the data set are pixels. Thus, these may not have been informative to the model. The model took less time to run, but was less accurate. The final project that I will discuss in this presentation is a Twitter sentiment analysis problem. With the popularity of Twitter, many data scientists have started collecting and analyzing Twitter data in order to gain insights on a variety of topics. For this project, I wanted to classify the data as being racist in nature or not. This problem was part of a recent competition hosted on a data analytics site called Analyticsvidia. This site holds many competitions for data scientists and contains many posts on current topics. With this data set, the information given were tweets and a classification of a 0 or a 1. A 0 indicated the absence of a racist or sexist undertone, and a 1 indicated the presence of one. Identifying the hateful tweets has become a hot topic in recent years in order to avoid any overly hateful speech possibly progressing into violence. The data preparation steps for this data set included tokenization of the tweets, which is a process of separating a tweet into words and characters. This is necessary to create a term document matrix, which is a structure used to quantify the text for analysis. After the data preparation, I was able to start modeling. I chose 4 different models in order to classify tweets: naive Bayes, support vector machine, random forest, and neural networks. As you can see from the slide, the neural networks ran the best. In actuality, this model took the longest to run. Taking into account efficiency, I would recommend an SVM model for classification of this dataset. An interesting point to note is that the dataset contained an unequal amount of positive to negative tweets. This did lead to better classification of the positive tweets compared to the negative tweets. This was corrected for by undersampling, meaning that the size of the larger class was reduced to the size of the smaller class. This solved the unbalanced dataset problem. However, for real-world applications, this is not realistic because there are naturally going to be more positive tweets than negative tweets on a platform. From the tweets, you can see some of the words that played a key role in determining if a tweet was racist or not. The words under the red bars are the ones that identified a negative tweet, and the words under the green indicated a non-racist tweet. In this presentation, I covered the goals of the Masters of Applied Data Science program at Syracuse and described projects through which I met these objectives. In my projects, I exhibited proper handling and preparation of data, from variable transposition of the larger continuous variables in the sports analytics problems to additional data collection of stadium sizes for teams in the NCAA. I portrayed an understanding of a variety of data types from continuous to text data, explained how to handle and analyze each one. I performed a variety of modeling techniques for the problems mentioned in this presentation. These included linear modeling and several machine learning techniques for classification. Finally, I displayed a competency in handling large data sets, particularly with the tweet data and the fashion MNIST dataset. I would like to thank all of my professors who have helped me and taught me so much during my journey at Syracuse. I am extremely grateful for this opportunity to learn and grow in an analytical field.